Good morning. Yesterday we have discussed about the Zener diode. Zener diode, how it is working as a voltage regulator, that we have discussed. Zener diode, what is a Zener diode? One mark question. Write the circuit symbol for Zener diode. 1 mark. Zener diode, is it works under forward bias or reverse biased? Carries 1 mark. It works only under reverse bias. Then action or working of a Zener diode as a voltage regulator, that carries maybe 3 marks. In some occasions we are asking for about 5 marks question, an important type of question. Okay, these are the ideas already we have come across. We know about diode, PN junction, forward bias, reverse saturation current, voltage, breakdown voltage, reverse bias condition, breakdown voltage, then AC resistance, means dynamic resistance. All these concepts are finished. You go through the notes properly, read the notes properly. Okay, yes. Now, in today's portion, I will discuss about first I will take up light emitting diode, and then I will take up photodiodes. Okay, first I will take up the photodiode. Yes, photodiode. What do you mean by this photodiode? 1 mark question. Under this category, either we are asking for 1 mark, usually we are asking for 1 mark question, or some occasion we are asking for 2 marks question, nothing else. Usually we are asking for 1 mark only. Okay, some occasion we are asking for 2 marks question. So prepare for 1 mark or 2 marks questions under this category. Today's portion. First idea, photodiode. Then photodiode circuit symbol, 1 mark question. Write the circuit symbol for photodiode. This carries 1 mark. We are asking like this only, write the circuit symbol for photodiode. Photodiode, you are supposed to write like this. Ordinary diode that I am writing, PN junction, a semiconductor diode. This is PN junction, a semiconductor diode. This is P and this is N. This is semiconductor diode. And extra idea, what is that here? Of course, this is cathode and this is anode. This is positive end, this is negative end. Extra concept, I supposed to show it like this. Light energy must be incidenting here. This is light. Okay, this is the light energy. Okay, when the light energy is incidenting, then only it will starts to work. That is the concept under the photodiodes. Photodetector, this is also called by the name the photodetector. This is a photodetector. A photodetector, this is. It can detect the light energy. Because when the light energy is incidenting, then only it will starts to work. Okay, this carries 1 mark. Write the circuit symbol for photodiode. Write the circuit symbol for photodiode. 1 mark question. This carries 1 mark. Now, photodiode, we are going to connect only in the form of reverse bias. Under reverse bias condition, it will work, not under forward bias. This carries 1 mark. Okay, so first concept, write the circuit symbol for photodiode. It carries 1 mark. Photodiode, it will work under reverse bias condition only. This carries 1 mark, not under forward bias. Okay, then how it is working? Principle, working and other things. A very easy concept. Just to see that, understand the concept. I will consider a PN junction here. This is the PN junction. Already you are aware of that. This is a PN junction. P variety is there, N variety is there. Under reverse bias, this charge depletion region thickness increases. Take your notes, read all the concept. You will come to know that any problem or something, if you're not understood, okay, you can inform me which particular part. This is P variety and this is N variety. Number of holes are here, majority charge carriers, electrons are minority. Number of electrons in N type is majority charge carriers, holes are minority charge carriers. This is containing immobile ions. Okay, no free charges. Immobile ions are present here. This must be connected in the form of P, must be connected to negative end of a battery or a cell. N variety must be connected to positive end of a cell. Positive end of a cell must be connected to N variety. Negative end of a cell must be connected to P variety. Then only this is said to be under reverse bias condition. This is reverse biased. Still I have not yet connected. Because I supposed to connect here one micrometer to measure the current. Okay, I will connect a micrometer here because the current is said to be a very small current. Microammeter, it is a reverse bias. I want to measure the current, which is a small current. And through a resistance, we are connecting, nothing else. If you want to connect a resistance, you connect, otherwise no problem. You can leave it. If the current strength is more, then we want to avoid this list, the larger current to flow here now. So for that purpose, otherwise no problem. We can connect a micrometer directly. Okay, what is happening here? This one explanation purpose that I have written. Circuit diagram itself, if I want to show it here, I can show the circuit diagram like this. This is the circuit diagram. Okay, this is PN junction. This is P and this is N. The light energy is incidenting here. Under reverse bias, I suppose to connect this. Under reverse bias, negative end of a battery, positive end of a battery must be connected to the N variety. And in turn that I will going to connect a micrometer with a resistance. Here I will connect a micrometer to measure the current through a resistance. Okay, this is the circuit symbol. This is in the form of reverse bias condition. It is a reverse biased P, negative end, N, positive end. It has been connected through a resistance and a micrometer to measure the current. Then, how it is working? So, meaning photodiode or a photodetector, it works only under reverse bias. Reverse bias that I have written with a micrometer, battery, and other things that I have written. Here, as the voltage increases here, current remains same. Take your notes afterwards, you read under reverse bias, semiconductor, forward bias, reverse bias, both the things, you will come to know that. As the voltage increases here, as if I'm increasing the voltage here slowly and steadily, here the current remains same. That current is called by the name reverse saturation current. So here there is a reverse saturation current. The reverse saturation current is a constant, which is a constant value. As you are increasing the voltage here, current never increases. Current remains the same in the reverse bias condition. The current, whatever it is flowing, due to the minority charge carriers, that current is a constant current, which is not depending upon this voltage, called by the name the reverse saturation current. That reverse saturation current is a constant. It is said to be a constant here. Okay, what will happen? The next concept here. What is happening here? As you are connecting like this, everything is having a breakdown voltage here. Here also it is having a breakdown voltage. Now let us consider this particular diode is having a breakdown voltage is equal to 5 volts. I will consider here for this one, the breakdown voltage is equal to, example, V breakdown is equal to maybe 5 volts. As an example I am quoting. Now, I will increase this one, the voltage to 4.9 volts. I will increase 4.9 volts. I will increase. Current remains same. Current never increase. 5.2 volts if you are giving here, current suddenly increases because here the covalent bonds are breaking up. More minority and the holes and the electrons pair is going to get produced here. More number of minority charge carriers. Because of that one, the reverse saturation current suddenly increases. That particular voltage is called by the name breakdown voltage. You are aware of that. But lesser than this breakdown voltage, current never increases. It remains constant. That is called by the name the reverse saturation current. Now I will keep this voltage little bit lesser than this breakdown voltage. Maybe 4.9 volts I will keep it. Now, here the current flow is not a larger quantity. It is a smaller and constant quantity called by the name the reverse saturation current. Now, if the light energy is incidenting on the PN junction, this is the light energy of a suitable frequency, suitable energy of a suitable light energy is incidenting. Suitable energy, suitable frequency, suitable wavelength is incidenting on this PN junction. Then this particular light energy produces more amount of electron hole pair here, and hence the reverse saturation current suddenly is going to get increased. Therefore, it starts to conduct here because the current flow suddenly increases. That's why we are going to write here the light energy we are supposed to write here. This is the light energy. This is light energy of a suitable light energy we are supposed to put. Then only current starts to flow here as a larger quantity, not this constant value. Suddenly the current strength is going to get increases. Again, I will repeat. Every diode is having a breakdown voltage. Let us assume, let us consider this particular diode is having a breakdown voltage is equal to 5 volts. Up to 5 volts, as you are increasing the voltage here, the current never increase here. It remains constant, is called by the name the reverse saturation current. I will keep this voltage to 4.9 volts, lesser than this. At 4.9 volts, closer to this, but lesser than this, current is constant, and that current is called by the name the reverse saturation current. As the light energy is incidenting on this PN junction, light energy of a suitable frequency, of a suitable wavelength, if it is incidenting on this PN junction, now here electron hole pair is going to get produced more in number. As the whole electron pair number is more and more here now, therefore here suddenly the current strength go on increases. Suddenly the current strength increases. So I can show with the circuit diagram, graph here now. I can show the graph like this. See that you can understand. So this is the graph. Reverse bias only I had to show it because it is said to be under reverse bias condition. This is in terms of microamps. This is in terms of volts. Okay, this is in terms of volts. But for the intensity, depending upon this intensity, don't forget practicals, you don't have that one. Okay, practicals is there in the degree classes about these practicals. We are increasing the intensity. Intensity means wattage of bulb. Intensity, number of photons per unit area is called by the name the intensity. Intensity means brightness of the light energy is more and more here. Now intensity is more. Number of photons per unit area is more. Photons per meter square is more. Intensity is more. As the intensity is larger and larger and larger, okay, then here the current is also go on increasing. So I can show it here. This is for the lower intensity. This is for the lower intensity. Reverse saturation current is there. Suddenly the current strength is go on increasing. So this is for one I1 value. This is for the next I2 value. Means intensity is more than this. I2 is greater than I1. Intensity of the bulb, intensity of the light, whatever it is coming out. Here it is incidenting on this PN junction, incidenting on that PN junction. That intensity, if it is more, current is also more. If the intensity is less, current is also less. That one we are discussing in the higher classes. Okay, yes. So this is the graph concept here now. So we are plotting the current, and the negative x-axis, negative y-axis we are plotting because it is a reverse bias condition. Already we have come across about this. Under the reverse bias here, as the voltage increases here, current remains constant. That current is called by the name the reverse saturation current. Let us keep the external supply of voltage lightly. Maybe it is a smaller amount of lesser than that of the breakdown voltage we are supposed to keep it. Slightly lesser than this voltage we are supposed to keep. 4.9 volts if we are keeping. Then the light energy of a suitable wavelength of the frequency or energy if it is incidenting, then that energy is sufficiently enough to break down the covalent bonds. Hence the number of electron and hole pair is go on increasing here. Then suddenly the current strength increases. This is the principle and working of a reverse, what is that? The photodiode. The photodiode, or I can say photodetector. If there is no light energy is coming here now, then current strength remains constant. Therefore, it can be used for the light detector purpose. Light energy from a source is coming out or not. That can be tested by using this. And using this one, at a long distance, we can switch on or we can switch off the switch using the light energy. If you are switch on the light, it is incidenting on this, it starts to work. If you are switch off the light energy, automatically it is going to get switched off within a nanosecond, 10 to the power of minus 9 seconds. Ordinary switches, you have to go there and you have to switch it on or switch it off. We have to do that. Here, just if you are switch on the light energy, automatically it is going to get switched on. If you are switch off the light, then it is going to get switched off here now. So automatic switching on and off, that can be done within a nanosecond here. So there are so many uses are there. If you want to decode optical signals, detection of optical signals, computer patch cards if you want to read it, then electric counters, wherever if you want to use it, you can use this concept. We can ask here, I said already, either for 1 mark question or 2 mark question we are asking. If they are asking for 1 mark question, write the circuit symbol for photodiode. Photodiode is also a photodetector. It can detect the light energy. It can detect the light energy. Photodiode, it works under reverse bias condition only. Then how it is working? Photodiode, this is the photodiode, PN junction, reverse bias I have connected, micrometer I have connected here with a resistance. Okay, the voltage supply is slightly lesser than this breakdown voltage. We are supposed to keep it. Then if the light energy of a suitable wavelength is incidenting here, covalent bonds are breaking up, number of holes and electron pair is going to get increases here. And hence the current strength suddenly increases here because of the light energy. If you are cut down the light energy, this current is said to be a constant current. Because of the light energy, current suddenly increases. That's all the concept here about the photodiode. Okay, we are asking even users also. We are asking users. We may ask for about 1 mark question or 2 mark question. Write any one use of photodiode. Write any 2 uses of or applications of photodiode. We can ask for about either for 1 mark question or for 2 mark question here. Okay, next one. Okay, what is that next concept? Next one, today's portion, LED. Okay, first idea, LED. What do you mean by LED? One of the examination, final examination, they ask this question. What is an LED? I wonder about that. Like this also, they are asking the questions. What is an LED? Light emitting diode. Abbreviation, if you are expanding, you will get 1 mark. Light emitting diode. Light emitting diode. Light emitting diode. Okay, this is light emitting diode. All of us, we have seen this light emitting diodes. All of us, we have seen. Probably you may not aware of that one, that itself is a light emitting diode, but all of us, we have seen the LEDs. LED nowadays, we are using almost in all the household articles also that we are using the LED. LED bulbs are available. Okay. LED torches are available. nowadays, whatever the new coming two-wheelers, the tail end bulbs and even the headlight bulb, they are all made up of LEDs. Traffic signals, okay, the bulb, they are all made up of LEDs. Okay, so there are so many number of applications are there under LEDs. LED, it will work for a long time interval compared to your ordinary. LED TVs are available. Okay, olden days the vacuum tubes are there. Then it has been replaced by the plasma TVs. Plasma TV, it has been replaced by the LED TVs. LED TV afterwards, it has been taken as Edge LED TV, Edge LED TVs. Then afterwards, it has been coming with the array of LEDs. Now it is coming as QLED, OLED, all these things. Organic LEDs are also available here now. So television sets, okay, high definition LEDs. So many types of LED TVs are available nowadays. Okay, they are all applications of LEDs. First concept, LED means light emitting diode. Light emitting diode, it works as electrical energy. It is converting in the form of light energy. It converts in the form of light energy. Of course, it is under visible region. What we can see. Some occasion, we cannot see the light also. But light is there, but we could not be able to see. Our eye could not be able to see all the wavelength. We can see around about 4,000 angstroms to around about 8,000 angstroms. We can see that around about 7,000. Even 8,000 also we cannot see. 8,000 is there, but we cannot see that one. Our retina is not sensitive for all the wavelengths. So that is it is visible only for a particular wavelength region, around about 4,000 violet color to around about 7,000 angstroms. That is red color. Violet to red color, we can see that. Other energies, light is there, but we could not be able to see. Infrared, we cannot see. Ultraviolet, we cannot see, but it is there. So anyhow, LED, it is the principle is said to be electrical energy. It converts in the form of light energy, nothing else. Electrical energy converts in the form of light energy. Photodiode is not like that. Photodiode reverse way. Light energy, it converts in the form of electrical energy. Photodiode, light energy, it is converts in the form of electrical energy. Because of the light energy, only current we are getting here. But here, because of the voltage, it is converts in the form of light energy. What is happening here? Okay, already you know about the concept of energy. E is equal to h nu, photon. You know, under the what is that, atomic physics everywhere, energy of a photon is equal to Planck's constant into frequency. But we know that c, velocity of light, is equal to nu into lambda, frequency into wavelength. Energy is equal to Planck's constant into frequency. Velocity of light in air or vacuum medium is equal to frequency into wavelength. Therefore, frequency is equal to c divided by lambda. Therefore, this becomes E is equal to energy of a photon is given by h into c divided by lambda. I will substitute for nu here. Okay, h as it is. Nu only I will substitute here. Nu is equal to c by lambda. That c by lambda I have substituted here. This is energy of a photon. Energy of a photon. Come to the concept. LED, it works as the electrical energy, it is converting in the form of light energy. Either visible or invisible region, no problem. It works under forward bias only. It does not work under reverse bias. But nowadays, the new LEDs are invented and it is there in the market already. It works even under reverse bias. But for your examination purpose, you have to write LED works under forward bias only, because some of the evaluators who don't know anything about the reverse bias condition LEDs are working, then you are losing the mark. Therefore, according to your syllabus, LED, we are supposed to collect in the form of forward bias. But some other multicolor LEDs are available in the market. If you are going to the market and if you are buying the LEDs with a multicolor LEDs, Then in forward bias, it produces one color. In reverse bias, it is producing another color. Gallium arsenide LEDs are available. But anyhow, according to your syllabus, let us stick on to that syllabus. LED, we are supposed to connect under forward bias. But photodiode, we are supposed to connect under reverse bias. Okay. Now, what is happening here now in the case of LEDs here? LED, I will going to connect like this. See this explanation. This is P and this is N. This is charge depletion region. Here holes are majority charge carriers. Electrons are minority charge carriers. In the case of N variety, electrons are majority charge carriers. Holes are minority charge carriers. This is the aluminum wire that I am writing, aluminum wire for the electrical connection. Now I will go into connecting this one. P variety must be connected to the positive end of a battery. N variety I supposed to connect it to the negative end of a battery with a little bit amount of resistance that I supposed to connect here. Okay. Anyhow, resistance is an opposition for the flow of current. This is a condition here. What is happening in this condition here? Here what is happening? Charge depletion region thickness is going to get decreased. Charge depletion region thickness is decreasing because the holes are repelled by the positive charge. Electrons are repelled by the negative potential. Electrons are having a tendency to move like this. Holes are having a tendency to move like this. But don't forget, in P variety, we are having the holes. In N variety, we are having the electrons. Read the theory properly, previous classes theory. The electrons are present in the conduction band. They are present in the conduction band. These are present in the valence band. Here the energy is more, here the energy is less. Here the energy is more, here the energy is less. Now the electrons, because of this voltage, whatever we have applied here now, the electrons are moving from here to here, falling on the holes. These electrons are moving here and it is falling inside the hole, means it is occupying the hole. But electrons, they are moving and they are occupied the holes. I will write like this, okay? You can understand the concept now. Electrons are moving here, occupied the holes. Holes are present here. Holes means it is a vacancy for an electron. Now the electrons are shifting from N variety and occupy the holes. Electrons are shifting and occupy the holes. But electrons are said to be in conduction band. They are present in conduction band. But this is present in valence band. Which energy is more? Conduction band energy is more. Valence band energy is less. So here the electrons are occupied from conduction band to the valence band here. Here energy is more here. Energy is large. Here energy is small. Therefore, the electron is jumping from higher energy conduction band to the lower energy valence band when the electrons are moving from N variety to P variety. It is moving from N variety to P variety to occupy the holes. Therefore, energy difference, whatever it is there here, that energy difference appears in the form of the light energy. This energy appears in the form of light. The question is why there is a light energy is coming. Because the electrons are jumping from conduction band to the valence band. Electrons are moving from N variety to P variety to occupy the holes here. Holes, it is situated at a smaller level of energy, whereas the electrons are situated at a larger amount of energy level here because it is present in the conduction band. The difference in the energy appears in the form of light energy here. Light is also a form of energy. If this is E2 and this is E1, E2 minus E1 is equal to h nu. E2 minus E1, Bohr's theory, E2 minus E1 is equal to h nu. If this is E2 and this is E1, I can consider here E2 minus E1 is equal to h nu. This is a concept. This is what is happening here. I will write that concept here now. What is that? If E2 minus E1 is equal to h nu, then h nu is equal to how much? E2 minus E1 is equal to h nu. But E2 minus E1 is equal to the difference between these two. The difference between these two is called by the name the energy gap. Valence band to the conduction band, there is a difference in the energy. The difference in the energy is called by the name the energy gap. That energy gap is equal to h nu. Because of this, I can write energy gap is equal to h nu. But energy gap can also be written as hc divided by lambda. Therefore, Eg is equal to hc divided by lambda. Because nu is equal to c by lambda, Eg is equal to hc by lambda. Therefore, lambda is equal to how much? Lambda is equal to here hc divided by Eg. hc divided by Eg. Depending upon this Eg means the difference between the conduction band to the holes or valence band. Okay, conduction band to the valence band, whatever the difference in the energy is there, depending upon that energy here, wavelength is going to get produced. If the wavelength is larger, it is red color. Wavelength is smaller, it is blue color. Okay, you are getting the LED colors. You are getting the LED colors in the form of maybe I can write red color LED is available in the market. Yellow is available in the market. Green is available. Okay, then blue is also available. Blue color LEDs are also available. Okay, we are having even infrared LEDs are available. Infrared LEDs, it is working, but we cannot see the light energy because our eye could not be able to see this. Okay, violet color we have not yet manufactured. Violet color we have not yet manufactured because the energy difference is very large. If the energy difference is very large, then only we are going to get the violet color. If the energy difference is smaller, we are getting the red color. If the energy difference is smaller, this is smaller here, lambda is large. If Eg is smaller, lambda is large. Lambda is large for this red color, 6,800 angstrom. This is around about 5,900 angstrom. Green color 5,460 angstrom. Okay, so here the energy gap, depending upon the energy gap only, depending upon the energy gap between the conduction band and the valence band here, the wavelength is going to get produced. Depending upon that wavelength, we are going to have either the red color LED, yellow color LED, green color LED, blue color LEDs are available. Right, understood? Your CD or DVD writers, they are all made up of red color LEDs, but now it has been replaced by the blue color. The blue color LEDs are available now. Using the blue color, we are going to burn the DVDs and other things where we can store the more energy. If we are using the blue color, Blu-ray, if you are using Blu-ray discs are available. Blu-ray, what is that? The laser beam is also available. Using that, we can burn the CDs and other things. We can store more data. We can store more data using the Blu-ray. But red ray, we can store a lesser data here now. In one CD or one DVD, we can store lesser data here. But here we can store more amount of data under computer science, that is. So this is an LED here now. LED we are using most of the occasions at your home to even factory side also that we are using the LEDs. Nowadays we had to think about that where we are not using the LED. Even for your vehicles we are using LED, at home we are using LED. If you want to save the electrical energy, it will work for a lower voltage with a good amount of brightness, with a lesser amount of heat energy, because it is converting the light energy only. Heat energy is said to be very less here. Therefore, LED are useful in our, at home also it is useful to reduce our burden in the case of electricity bills and other things. If you are replacing all the bulbs with the LED bulbs, your the kV, whatever the bills is going to get decreased.